Hey everyone, welcome back to this Everchain's Devstream. I have Zychronics with me here again tonight, and we're going to continue our work on the script parser. Where did we leave off last week? Oh, you weren't here last week, were you?
No, I wasn't.
It was just me all by my lonesome. Um, so what did I do? We finished the ops last time. I think I had started doing parameters and then gave up and just started working on the parser itself.
Sounds like a reasonable approach.
Yeah. Okay. Okay. Yeah, okay, so we are in fact live. YouTube is working. Can everyone in the chat hear us? Or the two people in the chat? Okay, so where I left off last time. Hey, Chocolate, how's it going? Oh, we got a few people in now. Alright, we're good. Hoping that the slight time change will mean that more people can watch and not less. Had a few people ask if we could start a bit earlier, and I mean, to be honest, I prefer to start a bit earlier anyway. Um, right. Okay, so what I had done here is, let's just run through this and make sure I remember everything. So I started working on the smarter parser. I've got the Discord stream up, right, Zychronics? Yeah, I do.
Yeah.
Okay, so we've got this new get entry points method, and what it does is it scans the first 16 words, and it does a few things. Since we discovered the unfortunate fact that there is not always 16 entry points, sometimes there are fewer. I don't think there's any that have more, but there are definitely some that have fewer. Just gonna open up the script that we were looking at here real quick as well. So yeah, we've got the entry point block here. So I've done a few things to try and determine whether a value is an entry point or not. First, to make sure that it is a multiple of 4, because anything that's not a multiple of 4 obviously is not an entry point. There's this looks like header function, which basically jumps to the location of this value here, like whatever entry point we're looking at, and it grabs the opcode. It checks to see if it is in fact a valid opcode, and then it verifies that the parameter count matches. So this kind of avoids like false positives of something that looks like an op, but isn't actually.
So will this handle some misalignment?
Uh, well, that's the start of handling misalignment, for sure. I did just realize we should probably be checking to see if the entry point is within the bounds of the file before looking up the header. But anyway, so yeah, it grabs the it fails to grab the entry points. Okay, let's figure out what's going on there. First off, it should definitely be up here. Let's run this again. Okay, so the first one works fine. Now let's see what the issue is here. 6A7C. Come down here. It is within the bounds. It is hex 58 or 88, which is null. I may have not finished implementing all of the ops. I'm just going to check that real quick. Actually, I don't need to open that. I can just open up our documents. Yeah, okay. That is the issue. Just didn't quite finish this. Could have sworn that we did, but apparently not. So fork is 86. And this fork. Parameters are index, address, and something else. Consume. Love all these no-ops. I'm guessing that this depth is actually just for debugging, but we'll include it anyway. Okay, so now it should work. Hopefully. We have 9 entry points. Is that correct? Oh, right, we are scrolled down. No, this script does seem to have all 16 of them, so we are failing on the 9th. Or rather, the 10th, I guess. Okay, so 5184. Is that correct? At the conditional jump, we have 3 parameters. Okay, what is going on here? Because oh, of course, this is a set, so it can't contain duplicates. So that totally makes sense because there are some entry points that are duplicated. Okay. Problem solved. So we have our entry points. We are pretty sure they are valid. I think at this point we can actually be like really sure that they're valid because we're checking entry points and everything. Or we're checking parameter counts and everything. So then we have this probe branch function. So this is going to start parsing the code at that entry point. So we iterate over each entry point, and we want to probe each branch of the code. Cycronix, can you look up what... I'm pretty sure that'll be monster index 27.
Sure, sorry. I was over a few minutes.
It's all good.
Monster index 27 is...
Pretty sure it's 27. Since it's script index 28. If I was smart, it would be Vampire Kiwi. Yes, okay, it's Vampire Kiwi.
Yep. That's correct.
Okay. So 69F8 is where we are jumping in. So essentially what we want to do here is almost just run the code. Skylar's vid says, has Sony or anyone given permission or distaste for this project? I'm super excited for its final release. We have not heard anything from Sony, positive or negative. However, everything that we're doing is above board. Reverse engineering is a bit of a gray area, but we do not redistribute any game assets whatsoever. Users still need to own a copy of the game to play it, since it requires the disks to get all the game files. So we're jumping right in with a Go sub here. So we're adding what I'm calling a hit. So a hit is a line that we know is code. So ideally, this set will, or this map will eventually basically have every single one of these opcodes in it with a count of how many times that opcode was hit. So let's start here. So we can reference the old code a little bit. So one thing that we need to make sure of is that we don't end up revisiting the same code path a bunch of times. Because we could very easily get stuck in an endless loop. So what do we need to do here? So we have jumped. Have we jumped? Yes, we've jumped already. We are at the correct location. And we can basically just start parsing. we can pretty much just mirror what is going on in the original parser. So we want to get the current command. Oops. Grab the op, and we are going to have to handle several different ones. We'll definitely need to handle the go sub, jump, etc. So, yield is fine, we don't need to do anything there. I think rewind, well, yeah, they might use rewind to signify the end of, well, there could be a rewind inside a conditional as well, so I'm not sure we need to do anything there. Don't need to do anything for these. So, I'm just going to stub these all out for now. Because these are all things that we are going to need special handling for. We also need to handle if the op is null. In that case, we will break out of execution, I suppose. So this is going to end up being recursive. Now that actually means, so this state object cannot handle recursion because it has an internal offset. So that is an issue. Because if we recurse on this function, it's going to set the offset, and then it's not going to restore it. I guess we could just back up the offset first. Old offset equals this dot state dot. I'm pretty sure it's current offset. What is this param count? Okay, so that's only used in the old parser. I don't think we're going to need this. Yeah, that's only used for the call op, so let's just pretend that doesn't exist for now. Now the params. Okay, so we're just going to not use those. I'm going to mark these as deprecated just so I don't accidentally use them. Why do I have both op offset and current offset? That seems kinda silly. Current offset isn't even current offset. That's some terrible naming, but whatever. Okay, I'm gonna get rid of these and
And
call
it's still
these.
working correctly?
Yep. Okay, I'm just gonna get rid of this method. I'm gonna rename this to current offset. Okay. And then at the end, we will return those values to their original state. I'm debating making this a stack. Um, should we make it a stack or not?
Well, what's the benefit turning it into a stack?
If we need to store more than just like a couple of variables, then it would probably be better to just have it as a stack. But as it is, it's probably fine. I mean, it's not the end of the world to turn it into a stack after. So let's just leave it at this for now. Okay, so our first op in here is go sub. I'm going to add logging here. I'm just going to use system out because I don't have a logger set up. If we run into invalid code, we probably just break out. Actually, let's do... Make an overload of this. No. I'm gonna make this, hey Doom. I'm gonna make this return the op. Or null. So here we can just do this dot parse header opcode. And then that will now check for invalid op or wrong length or wrong parameter count. My wife just got home and she said that she's a few minutes late because she had to stop and help wrangle a baby cow.
What an interesting way to end the day.
Yep. Sure is. Hey, Yunsha. I have no idea if I pronounced that correctly. Okay, so we have our op now. And we can get the parameter count from the op, except for call, because call has a variable number of parameters. So let's grab these. We need to advance. And we need to grab all of the parameters. Okay, so we're going to need to change this up a little bit here. Basically, we need to encode the number of words that each of these parameters takes. Actually, we might have that here already. Yes, look at that. Look at us go. We got the width already. Cool. Let me call this width. And we can add the width to each of these. Most of them are 1. All of them are 1 except for 12. No, unfortunately we did not actually... Oh wait, sorry. That is decimal 12. Which should be C. We did not look at the width of the rest of them. I think we can just count the advances. I'm just going to make these all 1 for now so they don't error. And then we just look for... Yeah, so they all end in advance except for the ones that I have not implemented. And then it's just these 2. Yeah, this is what we've been putting off for a very long time. Basically, we're working on rewriting the script parser. So a while ago, probably, I don't know, probably pretty close to a year at this point, when I rewrote the script engine, I also wrote like a really, really simple, naive script parser that works pretty well. Like this is all output from the script parser. We've marked it up a bit and reformatted some of it, but it's able to disassemble the script and kind of output something that people can read. And that's why we've been able to start doing like very, very simple script edits. However, it is possible for it to get misaligned because, as I said, it's very naive and sometimes it can start interpreting non-code as code. And then it can get misaligned because it thinks that a command starts like in the middle of data or something. And that's bad because then we have to disassemble it by hand. That takes a really long time. And another issue is that when we want to actually make a change somewhere, we have to recompile it by hand. Like actually take all of these ops, turn them back into assembly by hand, compute all of the parameter types, pick the correct parameter types, pick the correct opcodes. I made a like 7-line change, and it took me like 45 minutes to recompile it by hand. So, obviously that's not sustainable. We can't do that for anything actually interesting. So that's what we're working on here. So if I've done this correctly while rambling on about other stuff, this should skip over the parameters and let's go ahead and run this, see what happens. We get our first op. There should be a go sub. It is null. 6A80, is that correct? No. Okay, right, okay, so since this is a hash set, it's not going to iterate in order. The order of any type of hash table is basically arbitrary for all intents and purposes. Unless you have some sort of ordering mechanism like a linked hash table. It's just completely dependent on the hash function that they use. So why is 6A80 coming up as null? It is because I gave it the full opcode and not just the high byte. Right? No? Okay, let's follow this. So we jump to 6A80. 6A80 is this. 6A80 is this. So it should be a go sub. Current offset is 6A80. We do indeed get 148. Oh, this is the entry point. We should be passing in the address here. Yeah, that makes sense. Okay, nope. We're still getting null. Oh, it's because I'm just a dumbass. I copied this instead, obviously. The opcode is set to that. That is not correct. It should be this dot...
That's what I was hanging on you. I was confused. I was like, am I confused or...
Alright. Now it'll work. Yeah, okay, so we've got a go sub. Parameter count is 1, that's correct. Go sub just has the one parameter. We should... Oh, I didn't actually build the param, of course. by opcode, which is not actually an opcode. We got to do some renaming here because a lot of this stuff I wrote before really having a good grasp on the script engine itself. So I gave some stuff some names so that we could differentiate it. Those names did us well for a little while, but we know a lot more now and they're not really accurate. I'm just going to call this current word. I think that is the easiest. Yeah, and then we advance by the width of the parameter, and we also set params I equals param. Yeah, so we have an immediate parameter here, which makes sense. This is an immediate, it's just an address. If we look into the script here, you can see that it's just the, sorry, the parameter, wait, hold on, hey Dart, how's it going? Okay, what is our current word? It is, so that is what we're looking at. Okay, so we need to actually grab the, yeah, we need to grab the op here. Op is also the wrong word. We're going to call this param type. Right, because the go sub should be a relative offset, I believe. Yeah, inline 1. That checks out. It is 9. You can see parameter type 9 right here. And then this is going to be the actual value. Takes the current offset and adds the, yeah, this is kind of the weird part. It uses just the lower 2 and multiplies it by 4. That'd be F451 times 4 plus the current offset. And op offset should be header offset. I'm going to rename these as well. Yeah, this is starting to make a little more sense. So I guess since this is the first code that we've got, we will have to implement the go sub. We should probably keep track of where functions start as well, or subroutines, I suppose. So if we have made our way into another subroutine, we can simply fail. So like as you can see here, this entry point, simply it just calls this function here, and then it's going to continue on into the other entry point. We don't need to parse that again. And I think I am just going to convert those hits into a hash set. I don't think we really need to keep track of how many times. So we have a go sub. Now things get a little complicated here. So we need to get the value from the parameter. However, we can't always do that, because sometimes it relies on external values. For this one we can. The question is, how best do we do this? So we definitely want to be able to grab the values for the parameters that are available to us. Hmm. So I think probably the best way to handle this is if it is a parameter we can get the value of, then we should follow the go sub. Otherwise, we should not.
I'm slightly confused.
Um,
So
sorry, go ahead.
when we encounter a go sub, do we just want to get the address of the go sub and then continue with the next word in this case, or do we want to go there and figure out what it's doing and then go back?
Well, we want to go there, figure out what it's doing, and then come back. However, the issue is, what happens if it's using a offset from a parameter that was set in the game engine rather than in the script itself? Like, I could very easily write a script that jumps to a value that's stored in a game var, for example. And of course, we don't have access to those game vars unless the game is running and at that point. So we wouldn't be able to jump to that because we wouldn't know where to jump. But there are some that we do know. Let's return a optional here. So if we have an immediate, that's really simple. We just return the value at that address. Now we need the, we're going to need the parameter values here as well. So I think we probably just we can just do parallel arrays. That's fine. Let's parse param value, and it will do the advancing for us. So if we have an immediate, then the value is just the current word. For next immediate, it is pretty much the same. I think, yeah, command at needs to change to, we're going to call that word at. Storage we can kind of do, but at the same time we can't, because like a lot of the storage values are set in the scripts, but some of them are set on the outside. Other storage, other offset we obviously can't do because those are outside other scripts that are running in parallel. So here we get the word at the header offset plus the signed short value of the parameter times 4. And let's go ahead and run this and see if it works. So we're going to probe the next branch using, this should be if present, and then we can just pass that as the method reference. And then if we can't, then we log unknowable parameter, much like the unknowable horrors of the scripting engine. So if all goes well, this should jump us into that method. We get our go sub. Why is that saying array index out of bounds? Because that is parent parameter and not parent count. Sorry, param count. Alright, attempt number 2 with the correct code this time, probably. I need punctuation. Let's parse out the value. We get an inline. Our value is hex 208. I have a... Yeah, that's 3BC4. $208. Oh. Yeah, okay, so this is... So in this case, we don't actually want to dereference that. Yeah, we don't want to dereference that. We just want the address. Yeah, Doom, it was correct, but we want the address to it, not the actual value. Yeah, okay, so there. Now we've got the address here. And we will be able to... Yep. So yeah, we are now probing branch 3BC4. And we should do another go sub here. Our new command here is move. We do have a move. Should have two parameters. Let's see what parameters we got there. These are probably both, yeah, those are both empty because we don't know what those are. Let's see what the parameter types are. Yeah, see, those are both referencing storage values. Yeah, I mean, it's unfortunately a bit complicated. We might have to go a little bit more in depth in this. Okay, so now we move on to the next, which is a go sub as expected. Our destination should be hex 390. Let's take a look at our value. Yep, 390. Subfunctions are a little complicated because I'm sure that some of them can make the script jump. Like there's thousands of subfunctions, and I'm just positive that you know, somewhere in there they have done script jumps or whatever. So we are, Zychronics, eventually going to have to map out every single one of those subfunctions.
That sounds like a good time.
Yeah, that's not going to be.
Why you sound so down about it.
Maybe we can just get Ink to do it. He loves spreadsheets. Also, if we take a look at our hits, we should have some different lines here. We do need to be adding hits inside here as well. Yeah, we don't want to add the hit there. We want to add it here. Gonna have to back out of here since I changed that. Okay. Yeah, so we have the call opcode, which is exactly what we'd expect, the subfunction. Our parameters are storage, storage, and immediate, so we should be able to see the value of the immediate. It is 0. Easy enough. We do have to handle that somehow, but don't know how we're going to handle that yet. Yet we're followed by a move, and then a shift left, and then a... That's probably a move as well, and then we're going to have a return. Yeah, shift left. Oh, it's an OR. And then our return. Now Zychronics this begs the question of how to handle returning. For example, what if we have a return in a conditional like this? I can tell this is a conditional that will skip over this line, and this return won't always get hit, but that is much more difficult for a parser. Like
Yeah, if we're jumping around, we're gonna miss a bunch of stuff. How do you get the stuff in between?
Yeah, that is a very, very good question. So like if we kind of rework this to show the structure, so like if we were to have a return in here, then obviously we would not want to jump back when we hit this opcode. Oh, sorry. I did actually mess that up. There is a return in there. So really, we would only want to return at like a bottom level return value, but that's complicated.
Can you skip over the return and continue onward?
Well, I mean, we could skip over this if block entirely, straight to its destination, but then we would miss the code inside of there.
Yeah.
This is really complicated. Um, so I think if we see conditional jumps, then we can know that we are inside of a control statement of some kind. It's either going to be an if or a for, or an if or a while, I guess, since, for loops are kind of a higher level language construct. Well, I mean, I guess ifs and whiles are higher level too, but fors are just built on top of whiles. So we can know that we're inside of either an if or a while, and if we are inside of one of those, then we should not return, right? Does that make sense?
What if you just never return? What happens?
Then we might start parsing junk,
Oh.
since there can be data interleaved at any point. So, well, I just thought of another scenario where that won't work, because what if this was an else? Now again, with my human eyeballs, I can see that both branches of this return. So obviously, we should return at the end here. But that is also difficult to parse. Okay, I'm formulating thoughts. I think we can run this probe branch. God damn, this is complex. I'm gonna undo these changes before we forget about those. I'm sure this is some riveting television. I wonder if we start parsing out the branches every time it forks like this, and we return when every branch returns. Does that make any amount of sense at all? Even a little bit?
Yeah, so when you want to go somewhere else, you're going to continue in two places until you hit a return on both of them.
Yeah.
So you're going to continue parsing in two areas instead of one, and then if one of those areas wants to branch off again, it'll be three until all of them are done. That makes sense?
I think so.
But how are you going to know the order of things?
What a great question. Okay, so let's just start writing code and see what happens. If we hit a jump, let's write some pseudocode here. Um, recurse into probe branch for each branch. I guess for both branches. Um, exit. Because I mean, I think that's pretty much it. Because like the probe branches are going to run until they hit a return or something, and at that point, like all branches of this jump will have hit returns. So I mean, it's time to return anyway, right? Sure everything is working. Like OBS is back online. Just waiting for YouTube to catch up. Okay, I think we're good. I think we're good.
Oh yeah, the stream is back up for me on YouTube now.
Yeah, looks like we're back online. Okay. So as we were doing, We were going to fork execution. So I think we need to do basically the same thing we did for go sub. Yeah, we just have the address. And it's not state dot header offset. Is that correct? No, because we've already stepped at this point. Have we already stepped? No, we haven't, so that's fine. We can do that. So basically we need to fork at the destination address and also the current address plus 4. So we're going to say this dot probe branch, this dot state dot current offset plus 4, and we also want to probe the address. No, we want to break this loop. But only if we had an address. But we want to break the while loop. So I'm just going to put a label here. Because otherwise it's just going to break out of the switch case. And on a return, we also want to break out of here. So let's try this again. A second level go sub. This is the one going to 390. So we get our call, move, shift left, 4, and next we should have the return. Yep. So that's going to break us out of here. We're going to restore our old state. Wait. This is going to restore us back to the go sub, isn't it? Yeah. Can I really not jump away from 3BC4? Okay, so it is 2 go subs in a row. Is this going to have the correct address? Parameters. Yes, okay. So we're good. 3E1C. Okay, yeah, and here we've got some branching. So we're going to put this to the test now. Yeah, we've got to move up. We do need to fill out the subroutines. I forgot about that. Oh, this is a comparison jump. This is not a fixed jump. Right, Cychronics. A regular jump is not a branch. This should actually be comparison jump.
Oh.
A regular jump just straight up jumps, of course. So I guess here we just straight up jump to the correct value. This can just be a... And we don't break there. Okay. So we are in 390. Going to run till we get to the return. That is going to break us back out into 3BC4. which is going to give us another go sub, which will take us to 3E1C. We have one move command, and then we have a conditional jump. I'm down. Okay, I'm just going to jump back here. Oh, I did not recompile. Okay, let's try that again. We have our move, and then we have our conditional jump. Why? Okay, let's start this again, and I'm not going to be so trigger happy this time. So we did get a few conditional jumps here. So 3E28 is checking a storage parameter, so of course you can't check that. 3E5C is also checking a storage parameter. 3E94 is also checking a storage parameter. 3EC0. That might be an op that we got rid of since it was superfluous. However, it doesn't seem like it should be, since 3EC0 would be the first parameter for this command. So I think we have an issue here. But we've got a problem. Okay, so we've got our move. And we've got our jump. So, oh, I just realized something too. We're using the wrong parameter. Okay, so we do have to split this, actually. Or we could just do this. Since on both it is the last parameter. Okay, now we'll actually be looking at the correct address there, which is a step in the right direction. Okay, so let's look at our parameter values. Of course, our first one is unknowable, our next one is 3FBC. Uh, 3FBC. Yeah, okay, so we reordered some stuff here, so some of this is the addresses are all kind of all over the place. You can see we got 3F here, and then or 3F30 here, and then 3FD8, and then back to 3F44. We just reordered some of this so it flows better for a human reading it rather than a computer. So 3FBC. Yeah, so we've got one branch that we're going to run, which is 3E38. Should be... Okay, we don't want to do the +4 here. Since we've already advanced past the command that we're reading. Let me just check to make sure that the header offset is correct. Yeah, okay. So we're going to recompile this. I'm going to jump back to the start of this lambda. And we are going to probe the inner branch. 3E34, that is correct. We should have a call op here. We do have a call op. Now we should have a, yeah, we've got a move, and then we will have another conditional branch. Wait, a ship left? Oh, sorry. Yeah. Okay. Everything's fine. Now, yeah, we've got our comparison again. Well, not again, but another comparison. And our, yeah, we've got an address here, 3FBC. So that will also be jumping out here. We are also probing 3E6C, which is in fact this next one. Our next probe should be 3EA0, and it is. Then it should be 3ED8, 3EBC. Oh. Wait. Three EA0. Why do we have this op here with nothing on it? Let's see where we go from here. 3ECC. I'm guessing we have deleted some stuff in the middle here. Well, I'm hoping that we have, at least. We have an AND command. Okay, so the ANDs are... Yeah, okay, so we had some commands in here that I combined. This was outside of here. Yes, and now we have our jump to 3EE4. Yeah, so we're still all good here. We will have a go sub to 1F70, which we do. It's actually working pretty well so far. Famous last words and all. Oh, this is some ugly code. This is like multiple branches that, yeah, all jump to down here. Okay, so yeah, it's disc artifacts. Okay, it kind of makes sense, but it's ugly, but oh well. So this is going to be 3 calls, a jump, a bunch of calls, a while loop, a bunch more calls, and then down to a return. Let's see if it handles the jump correctly. Second call with a bunch of parameters. Third call. Even more parameters. Now we should have our jump. We do. Let's check our jump parameter. Yeah, 24C, that is correct. So once this runs, right now our state dot current offset is 1FBC. It is now 204C, which is the correct jump destination. Should take us back up here. We step. Opcode is call. Yep, jump worked. Now this is just a bunch of calls. I do want to see this loop. Got the move. And then we've got the wait. Yeah, okay. So that's good. I'm just going to run until we get to the return. We're back at 3EE4. Um, Oh, that's the offset. That's the original offset, not the offset we're currently at. 3ED8. No, that's also wrong. We just need to look at the current offset and stop looking at all these other variables. 3EF4. That is where we're supposed to be. We've got to move. We've got to jump. That jump should be to 3FD8, which will be a return at the end of the method. Let's check and make sure. 3FBC, that's probably close enough. Oh, that checks the damage cap. That's going to be some more conditional jumping. Our jump destination is 3FD8, which is expected. That is the return. So we are going to fork here again. Now this probe that's doing that move. Parameter should be a very large number, yep. And then this next, what do we got next? We've got return. Okay, so this is the first time that we're actually jumping back out of one of these branches. So now we probe the other branch, 3FD8, that is what we expect. And we've got a return here as well. And now we are breaking because we have exhausted all execution paths. Now we're back out here, 3F44. This is another branch. Okay, this is this outer branch here. I don't think we made it into this branch, though. Let's keep an eye out for jumping into 3F20. It might just be happening in a different order than what we would expect because of the way the ISM is laid out. Okay, so we have a call, and we've got some other junk down here. Another comparison jump. This one goes to 3F74. That is expected. Let's just skip over these ones. Oh, we've got another goes up here, 1FB, 3F90. Oh no, that's not a Go sub is just because we are doing the branching. 3F9C. Now here we are going to have a go sub. And we are in 1FBC now, which is just a different branch of this guard effect. Hey Icarus, we're working on the much more advanced script parser. Currently working on probing branches of the code to see what is code and what isn't. It is going better than I expected it to. I'm going to jump right to the break here. Okay, so we're back at 3FBC. We are going to get another conditional here. 3FCC is taking us into the condition. Jump out 3FD8 is taking us to the return. Jump into the return. We break again. Yeah, we are at 3F9C. Which is also this branch. 3FA8. Is going to be another jump into that method, the same one. Yeah, 1FBC. We will just go straight to the return. Where are we now? 3FB0 again. Now we're at 3FBC. 3FCC is correct. Gonna go to the return. Probing 3FD8 is also the return. We'll jump in here and then just jump straight back out. That's the end of that. We are also jumping back out of wherever we are here. 3F90. Probing 3FBC as expected. Can jump straight to the return. 3FCC. Can jump to the return. 3FD8 is the other branch. Returning again and again. 3F7-4. Yeah, this is all just kind of working. I'm sure there's gotta be spots where this would break down.
Hello there.
What's up, Drew?
Is your PC doing better?
Nope. Blue screen
Nope.
wins.
Well, I hope you're as close behind me. I've managed to solve my terrible streaming issues, so it's your turn.
Yeah, well, I was going to set up, I was just going to switch over to my laptop for this stream, but for whatever reason, my laptop will just not output video to the TV.
Odd.
And I ran out of time to mess around with it.
Well, I think that settles it. We're going to need a shared office space, like a whole workshop for our streams and everything.
That sounds like quite the commute.
Not if you move. Dot, 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 dot.
To the US. I don't know about that.
No, I don't want to be here either. We'll go to a space station, okay? That is my ideal haven. I'm sure you'll be fine with it. You can have anti-grav parties and everything.
Alright.
Seriously, though, good luck.
Thanks. I think I don't know if it's just this build of Windows or if it's my motherboard failing, but like I keep like failing to connect to the network, like a wired connection as well, so.
So it might be one bad Mobo.
It's either this build of Windows, which is fairly likely, or it's a motherboard issue. But I'm just going to get my laptop set up for streaming before the stream next time.
That's a good idea. You carry on. I'm gonna try and make some additional events for the next few weeks for us.
Good call. Alright. Well, thanks for dropping in.
Of course, if you need me, let me know.
Yep. I will need you to end the stream when I'm done, since
Okay.
I still can't connect.
I think I'm done driving for the day, so I will be here.
Okay, cool. I'm not entirely convinced that we aren't stuck in an endless loop right now, but it might just be because it's probably just because there's a bunch of different branches here that can all eventually end up taking the same code path. I have not done any optimization yet to make it so it doesn't take the same branch over and over again.
Just let it rip.
Yep.
Why not?
I do want to keep following it though, just because I want to see what happens when we finally get out of this mess.
Yeah. The 2008 is new. I haven't seen a number that starts with 2 in a while.
Oh yeah, we did get into here. That's good. We are going a bunch of layers deep here. Oh my god. Settle down. We are getting close to the end of this mess, though. I should have made the logging show how many layers deep we are. That would be useful information. We must be getting close to the end.
That is what you want to think.
I do really want to think that. Like it's taking a lot of these branches over and over again because a lot of them end up in the same place and some of them are kind of deeply nested.
Do we need to grow the same branch?
No, I plan to add a optimization that will track what branches have already been taken. And just bail. Good lord. Okay, we're backtracking out of a lot of branches now. A lot of branches. A lot of branches. Where is 3F08? Um, 3F08, where are you? Must be the else for this branch. Okay, yeah, we're back in the 2008 branch again.
Well, I mean, you were wondering when it will hit that piece of data.
I was. We have our answer. I am at least somewhat regretting not adding that optimization first. However, that is kind of dicey. We don't exactly know if it will work or not. Doesn't hurt to do a full run first. Don't optimize before you actually know if something's gonna work. Trust me. Just hoping I don't blue screen again while in the middle of this. And no, I do not believe in jinxing things. So many branches. This is why exponential code is bad. Remember when I said we've got to be close to the end?
Yeah.
That's going well.
I think we'll be here for another 10 minutes.
I don't think it'll be that long. I think we're almost stepping out of this mess now. And we're jumping back into a bunch of shit.
That is the insanity talking.
This reminds me of back in the day before I had rewritten the script engine, and debugging script bugs would literally be like a 3-day ordeal. Like literally a 3-day debugging session of just jumping, like just like window beside window, like emulator, comparing emulator severed chains.
I only know half of them, and even that one half was horrible.
Yeah. Oops. I mean, this is a really good visualization of the actual like exponential nature of every possible permutation of all of these if statements executing, and how many different potential paths there are through this code. Yeah, exactly, Doom. At this point, with the amount that the new Sever Chain script engine has been tested. Anything that pops up any bugs that pop up are definitely resale bugs, and we have run into a bunch of those. We found out earlier today that there's just a bunch of bugs on the Mayfill submaps. Ooh, something new. 9B0.
9BO. What is that?
We made it out. Okay, where did we jump from? Unfortunately, I don't know if this value is still going to be correct. No, it's not. So we can come up here and look at the address. What do you mean you can't find address? Oh, I've got to pop all the way out here. Offset is... Wait. Oh, right. We did 2 layers of jumping here. This probe branch, and offset is 3C48. Um, Go sub 9B0. Okay, yeah, right down here. Yeah, so all of that entire giant nested mess of code was just for applying shields.
Well, it makes sense that they didn't want to add perfect shield.
We do have some minor recursion going on here, but it shouldn't be too bad. Shouldn't take nearly as long to jump out of it. Are we back where we want to be now? I think so. Next op is move 0. Yeah, 3C, 6C. And then we've got another return. Three C50. Okay, so yeah, we're still in the nesting here. Yeah, we found a few old Todd files. Who knows what they were originally planning on doing with those. I tested some of them and they're all empty. None of them do anything, unfortunately. Would have been interesting to find some unused animations, but no such luck.
What do you mean? There is some.
More so than what we had originally found. Though I don't remember what has been found.
There's also unused graphics for enemy moves that
Oh
I
yeah,
can use. That's not just the Kamui spear.
interesting. I wonder if we could use any of those to make some new stuff. Doom game vars are basically just variables from the game engine that scripts are allowed to access. It's all kinds of stuff, like battle object IDs and even like the background clear color and stuff. Okay, so we return from here. Probing yet another branch. Okay, and where are we now? 6A88. Um, yeah, okay, so we did fully, yeah, we fully ran through this entire entry point with no issues. So let's put a breakpoint here. Gonna get rid of this breakpoint. And see if it runs without crashing. We have broken the JVM.
Well, that's fun at least.
It's something. Oh, I think we broke the IntelliJ logging. Also, I'm kind of concerned that this says T colon when I do not have a T drive.
What virus did you pick up?
It is still running. Like this is where it just paused at. So the code is actually still running. We just broke the IntelliJ logging.
But why is it running for so long already?
We're probably stuck in an endless loop. That does make sense. Yeah, like look right here, we've got an endless loop. This is the main entry point. That does make perfect sense because the combat scripts are endless loops. Otherwise, they would end, and the AI would stop. So, we need to actually implement this. And I mean, it's pretty easy. That should be it. So we should... Okay, that obviously didn't work fully. Oh, yeah. Duh. This should just be up here. We somehow made it into an invalid op. Probing branch 551C. Five five one C is a no-op. That's not the last file we opened. None of those are the last file we opened. Oops, script disassembler. What was that number? 551C. Why am I scrolling? Okay, so that is command 60. Hex 60. And these are all in decimal. 96. Okay, well, I mean, we do have the 96 there. Oh, it's because the parameter count doesn't match. So I guess that should have a parameter count of 2. We must be in the outer loop now, because it's just running forever but not actually probing anything. And come to think of it, yeah, that jump is not going to end anything. So Okay. Instead of this, I am going to have it use the probe branch. And exit here, and that will implicitly give us the, that'll implicitly give us this breakout. Okay, we got Stack Overflow, probably. No, we broke the logger again. We seem to be stuck probing the same branch over and over again. But why would that be the case? Oh, obviously because that's wrong. Invalid code, 53DC. That's probably another no-op. No, it's a subfunction. What is our actual address? 54A8. That should be correct. Maybe I have the wrong number of parameters there. Command 56. 56 is call. Okay, I'm going to get rid of this breakpoint, and we're going to move the breakpoint into here. We're going to convert this ternary into an if statement so that we can put breakpoints in here, and we're going to run it again. We have a wait opcode. A4. Is that a table? No? It is in fact a wait. Ah. But it does... Wait, no, this is a table for sure. Yeah. Okay, so we've got some more stuff that we need to consider as endpoints. Because we are actually hitting endpoints there and just not handling it. Call is a maybe. Jump table, we definitely need to do something with this. Go subtable, we need to do something with this. While we can just ignore. Okay, so deallocate will always end the branch. Now deallocate other is tricky because it can deallocate itself, but we don't know what our script index is. We need to do something with these. Okay, let's try running this again. We're getting invalid data at the same spot. Now the question is why? Because we also need to stop at a rewind. Yeah, we just handle it in the same way as a return, I guess. Okay. I put the comma inside of the string. My bad. Hey, look, we parsed the entire thing.
About time.
Alright,
That was quite the journey.
that's some major progress, though. So we now have...
See the output? It's not programming branch.
So we now have a list of the start of every single code branch. From here, we'll take this a bit further and probably, I would say we'll probably expand this to actually log like every single opcode, um, and then we'll just literally have an address of or a list of addresses that we need to disassemble. All right. We got there. That being said, I think I'll probably call it there. Do you have anything else that you wanted to discuss or anything, Psychronics?
No, I'm good.
All right. Any questions from anyone in the chat? I'll just give that a minute to catch up. Yeah, you're welcome, Chocolate. I'll take that as no one else has anything to say. So thanks to everyone who tuned in. Hopefully next time I will have everything moved over to my laptop, so we won't have to worry about restarting the stream halfway through at least once. At least we were good to go to restart it this time, unlike last time. But yeah, I'll get my laptop set up before like 20 minutes before the stream. I'm just like frantically digging through boxes trying to find like new HDMI cables, like seeing like is it the cable, is it the laptop, is it the TV? Anyway, we'll get back to this next week, or maybe I'll work on this a little bit throughout the week and see what we can get together. Thanks to all of my monthly supporters, my founders, The Packle, J-Man001, Deningrad, Sparta, Shepard, and Dart, my researcher Zach, and my mercenaries Vorthod, Chocolate, Platinum Sarge, Doom Metal, Milk Lizard, Matt, an anonymous donor, and Vince Easter. Drew has kindly sent a link in the chat to my donation page if anyone wants to encourage this behavior for some reason. Thanks everyone.